Hi, I'm Lisa Bagley and I'm the Ecosystem Manager for Barclays Eagle Labs Farm in Lincoln. Thank you for joining us today for this, our fourth session within our Agri-Tech Awareness Week. So today we are looking at Future Forward, the Agri-Tech of Tomorrow, stepping out into the sector, next steps. Before we talk to Simon, I do have a quick mandatory disclaimer I need to read. We have asked Professor Simon Pearson, Director of the LEA and Professor of Agri-Food Technology, to join us today to provide some tips and tricks on how effective collaboration between academia and flourishing tech businesses is supporting the sustainability of the agricultural sector and the food supply chain. The topics discussed are an overview of options for you to think about to help you with your independent research and business decisions, so aren't intended as any recommendations or advice. Remember as well that your business has its own individual circumstances, and the statements and views expressed may not be applicable or suitable for your business. So, Eagle Lab Network. Barclays UK operates the UK's largest network of business incubators. Eagle Labs has a combined community of over 650 technology startups and has 25 physical locations across the UK. From the Channel Islands all the way to Aberdeen, the majority of these are tech agnostic. Eagle Labs brings together a community of startups, innovators, industry specialists and mentors to create an interconnected ecosystem. We aim to support the acceleration of startups, transform corporates and empower future skills. As I mentioned, most of these Eagle Labs are tech agnostic. However, as I said at the beginning, I am the ecosystem manager for our very first Eagle Lab farm. In October, we will launch the eagerly anticipated Eagle Lab Farm incubation site in partnership with the Lincoln Institute of Agri-Food Technology, a dedicated facility designed to offer agri-tech entrepreneurs access to world-class resources where they can develop new technologies to support sustainability, efficiency, productivity in the food and farming industry. So what makes the farm different is the facility is geared at supporting research and development. The incubation space comprises of 30 desks and 4 offices that can be hired on a monthly basis, all with the added benefit of on-site ecosystem manager and lab manager who will look after to facilitate networking and connections with the world-class research team in the LEA and the Lincoln Agri Robotics team. The farm itself has over 200 hectares of arable land containing 160 sheep and 80 cattle, as well as 5G capabilities for data collection and upload. A prototype polytunnel which has specifically designed roof to maximise lighting, containing raised strawberry beds which Saga are currently using for their world-renowned strawberry picking robots, as well as the irrigation trials on the beds themselves. We have an indoor and outdoor robotic trials area, be the outside on the crop beds used for the agronomists or the internal replica site for demonstration and teaching, as well as a large multifunctional engineering workshop. Then to support the field to fork supply chain, we have a model refrigerated supermarket pack house. And for when we are back to the physical events, we have an event space that comfortably accommodates 50 delegates. So, what is the vision of the Agri-Tech programme? So our vision is to accelerate the UK's agricultural industry's adoption of emerging technologies to increase efficiency across the food supply chain from field to fork. From growing more food with less resources to the use of robots for planting and picking and demonstrating how AI can improve resilience, we're empowering the industry to make better decisions on how to improve their businesses now and in the future. Agri-Tech Eagle Labs are tailored specifically to support Agri-Tech by giving them access to Eagle Labs network and the opportunities that it brings. So what is the vision for Agri-Tech programme? Our vision is to accelerate the agricultural industry's adoption of emerging technologies to increase efficiency across the food supply chain from field to fork. From growing more food with less resources to the use of outdoor robotic planting and picking, and demonstrating how AI can improve resilience, we're empowering the industry to make better decisions on how to improve their business now and in the future. Agritech Eagle Labs are tailored specifically to support agritech businesses by giving them access to the Eagle Lab network and the opportunities that it brings. So why are people talking about agritech and the food supply chain? Now, global population is predicted to grow to 9 billion by 2050. So the question that follows is, if we have all of these mouths to feed, how are we going to feed that growth? And depending on which report you read, 60 to 70% more food is needed, with some reports stating near on 150%. This doesn't take into account that a third of all food produced is wasted before it hits the supermarket shelves. So when we look at that extra food needed, it's not just about the food grown, but also looking to reduce this amount of wastage. So what's happening currently? The food industry faces enormous systemic challenges. Technology adoption is likely to occur in measured steps, and most farmers and food producers will need technology that can be introduced gradually, alongside and within their existing production systems. So our vision is a new generation of smart, flexible, robust, compliant, interconnected robotics and autonomous systems working seamlessly alongside the human co-workers in farms and food factories. To deliver this vision, the research and innovation needs include the development of robust robotic platforms suited to agricultural environments and improved capabilities for sensing and perception, planning and coordination, manipulation and grasping, learning and adaptation, and interoperability between robots and existing machinery, and human-robot collaboration, including the key issues of safety and user acceptance. A fully collaborative approach is being delivered where tech companies, other areas of expertise such as academia work hand in hand with farm and business. So we're really privileged to have one of those experts join us today, where he can tell us more about the R&D and collaboration being undertaken in this fascinating area. He will also chat around some of the collaborations being undertaken between academia, farm businesses and emerging tech companies. So for this, our fourth session, Future Forward, the Agritech of Tomorrow, stepping out into the sector, the next steps, I'm proud to introduce Professor Simon Pearson, Director of LEA and Professor of the Agri-Food Technology.
Okay, thank you, Lisa. That's a brilliant introduction. And so I'm Simon Pearson. I'm Director of Lincoln Institute of Agri-Food Technology at the University of Lincoln. We're based at our Rhizome campus, and absolutely delighted and thrilled to be collaborating with Barclays Eagle Labs on this new venture. So, and what I'm going to talk about now is just a few thoughts on the future of agri-technology and where I think the direction of travel is going. So, as I said, we work at a Rhizome campus. It's a stunning location. The Eagle Lab is right in the heart of the campus, and you see a big picture of the campus with the lake and everything, and the Eagle Lab is right in the middle of it, and it's a stunning location. LEA itself is in the Great Hall, which is the picture on the top right, which is the old Bishop's Palace for the Bishop of Lincoln, where he used to spend his winters, and that's now where the institute's based. And then we've got some brilliant facilities. So we've got robots. You've got a Saga robot in a tunnel. We've got a full robotic fruit farm. We've got a ton of equipment. We've got a 5G testbed facility. Lots and lots of people. I think a portfolio now of about 65 PhDs on the books for the next 8 years, and loads of staff doing some great things. And it's a great environment to work, not only to create new businesses and new opportunities, but also a great, it's becoming a bustling community once COVID abates, and we're all looking forward to getting back. So what have we got? So this is just why have we got to where we are? So we've been very lucky over the last 5 to 6 years to secure very significant government support for the agri-tech work that we do. Our biggest grant probably is Lincoln Agri Robotics. That was 30 people and lots of equipment coming in to do new research, new development. We're working in all areas of robotics. We have a CDT, Centre for Doctoral Training, that's Agri-Food, so that's with Cambridge and UEA, so great connections into the rest of the UK research community around robotics. I run something called the Internet of Food Things, which is an EPSLC network, which is on digital technology in the food supply chains. That's AI, machine learning, blockchain, connected supply chain technology, digital twins, and all those sorts of technologies to connect the supply chain. And then we've worked for many years with Ceres, which is a Research England initiative out of University of Cambridge with Reading, UEA, Hearts, NIAB, Rothamsted, Earlham, all as key partners. So we're very connected in the community. So we and what we think, what we've really learned is that in agri-tech, collaboration is key. It's I think people can go so much on their own, but they go so much further if they collaborate, and that is our absolute ethos at NIAB. So why has it we got to change? Well, we know. I mean, this is just a great thing. This is just a picture of a John Deere tractor. That thing weighs probably about 6 tons, and it's trying to plough in impossible conditions. The future of food, in our hypothesis, isn't going to be that, because you've got climate change going on, you've got environmental damage, all sorts of issues associated with agriculture. But as Lisa said, we've still got to feed the planet. We've got a responsibility to think about how we're going to do that. And in England particularly, and the UK, is agriculture is changing with the new Agriculture Act and ELMS, Environmental Land Management Schemes policy. We're seeing a real change in farming, and part of farming will de-intensify, so we're going to see less food produced, but we've still got to eat. So our responsibility, the LIAT and the ag-tech responsibility, is on the other side of the equation, and that's to try and produce food more sustainably with lower environmental impact. And so we've got to think about how we do that. So robotics, we think, has got a really core role. We've been doing this for the last 3 years, I think 3 to 4 years, very actively. And when we think about ag-tech, what we try to do is think about the question ag-tech, and this is just one that people might want to think about. When we looked at the future of robotics, we asked a question, and that question was, what can robotics do for agriculture? And then we reversed that question and we said, what can agriculture do for robotics? And when you think of ag tech, I think you always have to ask that question. You have to reverse it to think about your customer, which might be agriculture, or your customer might, or your supplier might be a robotics company. So we tried to reverse that question. We did a review, and what reason we did that review was really to try and define what the opportunity was. And this chart on the left just shows what the opportunity is. And so in the top bit, the green areas, is what can robotics do for agriculture? And we saw 3 areas: selective harvesting, crop care, which might be robotic weeding, and phenotyping. So we're very crop focused at the app, not exclusively, but very crop focused. And then the bottom is why is agriculture interested in roboticists? Well, it's a brilliant place to be. So you imagine picking a strawberry; it's really, really, really difficult. And so you've got to have manipulation and grasping that can pick a strawberry without bruising it, effectively without touching it. You've got to have image processing to recognize it. Then you've got to have the control system to actually move and actuate to pick it. Then you've got to have autonomy. So you've got to have lots of these robots all over the environment. And one robot won't do it. You've got to coordinate them as a fleet. And the data scale is just immense. So you need things like 5G. So as a roboticist coming into agriculture, it's a brilliant place to be. So it's very attractive on both ends of the equation. So just to go through some of those opportunities, there's 3 areas that we highlighted. So selective harvesting, one, and fruit picking is really very important. And why is that? Well, it's unavoidable demographics and politics, and you can't help but notice in the press that there's a real crisis at the moment on access to seasonal migrant workers on farms. 69,000 seasonal migrants come and pick pretty much in the UK each year. And then when we were looking forward our research strategy, we could see Brexit coming up. And then, of course, you've got COVID layered in and all sorts of issues with availability of labour. And that's in the United Kingdom. If you go globally, you've then got the same issue in the United States. So you've got Mexican worker access and all those sorts of things. When Donald Trump was kicking around, that's a big issue. I think it's still an issue in the US. And then you go to a country like China, and this top thing just shows the demographics of China from 2010 to 50. The bars are the age profile of Chinese population. 2010 is relatively young, but because of the one-person family policy, they've got an aging demographic, so that population getting old, they need robotics. Average age of farmer in Japan 69, in the UK it's 59. So these are real mega trends which are affecting the availability of workers in farms. So robotics has got a role. So how do we do it? And this this talk is about the future forward, but to do future forward, it's often useful to look at the past, and just as an example of how we looked, where we were looking at 2016 in our vision, and we worked very closely with Berry Gardens, a fruit cooperative. Again, collaboration of industry is key. We scoped the future for robotic farming, and that future was polytunnels, which is done, tabletop strawberries, you can see. And then we saw robots picking fruit, we saw robots logistically moving fruit, we saw robots scanning fruit with cameras, we saw UAVs, and we saw use of machine learning for crop forecasting and all those sorts of things. That was our vision we put to the Berry Gardens board in 2016. And then what we've tried to do over the last 3 years is deliver that vision. And I think when you have a vision, it's very important you try and stick to it and don't get too distracted. And the problem with tech is there's so many wonderful things you can actually go and do. The key, I think, is trying to deliver them. So we work with Saga Robotics very closely at Lincoln for the last few years. The hardware was Saga's a spin out of NMBU in Norway. But most of the UK teams in Lincoln, and a lot of the software has been developed with research out of Lincoln. And they have a lightweight robot which can traverse fields, about 150 kilos, 2.6 kilowatts of power, can carry about 200 kilos. It's a lovely, lovely agricultural robot, very well engineered hardware. And then we've looked at that to develop a number of tools. And one of the tools that we've applications, one of the key things is autonomy, and this just shows the autonomy of the robot working real time. And if you've got an autonomous robot, you can do lots of things with it. You can do UVC treatment, crop forecasting, logistic support, and all those sorts of things. And this just shows why autonomy as a robotic platform, as a robotic tool, is so important. And this shows the robot going in autonomously into crops, treating crops with UVC. And this just shows the robots now in Kent. We've now got 8 robots in Kent, or Saga have, and this just shows the robots going up and down, treating fruit crops with UVC in Kent. And I can tell you now that those robots from March 2020 have now done over 1,000 kilometres of autonomous operation in Kent, treating crops with UVC to reduce powdery mildew. So that's quite an achievement, and that technology is starting to prove its worth. If you can do autonomy for UVC, you can move fruit, you can do fruit logistics support. So this is moving fruit around. This is a trial we did in Kent 2 years ago, actually. And what you do here, using the robot to pick up fruit from pickers. The picker calls the fruit with a mobile phone. The robot then identifies where the picker is in the greenhouse, and then goes to retrieve the fruit. So 20% of picking time is walking. What we see here is 2 pickers moving across the greenhouse, picking away, and they're going to call a robot any minute now. And that robot's going to find those pickers, goes to them, stop safely, transfer the fruit, and then take it back to the pack house. So a great example of autonomy. And this is so we've been delivering the vision we set in 2016. If you remember that earlier slide, it's pretty much what we showed, and we're getting very close to that. And the final thing we're working on now is fruit picking, and this is a project called Grassberry with UOL, Saga Robotics, a startup company called Phenotyping are involved in this, and we're now making real progress on fruit picking. We're also really proud that we've done a lot of our own research, and particularly the image pipeline for strawberries. And this is a PhD student, Raymond Kirk's work, and where he's using fruit recognition to do crop forecasting. So it's machine learning at its very best. So you can identify the berries, we can size them, we can mask them, we can reconstruct them in 3D. We can simulate the whole farm in 3 dimensions if we want, so that you can heat map where the fruit are on the farm. And the way that we do the picking, the recognition is really cool. So we're using very advanced technology to detect the fruit. This is blob detection, which is doing the counting, and then some very clever algorithms to recognize individual fruit, which is what we're seeing here. So we can recognize individual
The first one will be fruit counting. What we're going to try and get you to do is count faster and more accurately than it can.
So how does it count the strawberries? What is it looking for?
Yeah, so we use vision. It's going to use this camera right there, looking at the row, and it's going to detect the position of the ripe and unripe strawberries.
This space tech strawberry counting race is on. It's time for me to pit my wits against this robotic rival. 3, 2, 1, blast off. The fruit count is on, and I'm giving it everything I've got.
So that's where we demonstrated Raymond's work on Countryfile. We were prepared to take a risk that we could beat Countryfile at fruit counting, and we did. We were faster and more accurate than the presenters. So the research is really maturing, and that's the work of one PhD student. And if you're a startup company, you want to come into Lincoln, that's the sort of thing you can do. You can create these new products. You can achieve these goals. It is definitely very deliverable, and there's lots of support for people to realise their goals. So that's what's going on with Saga. So Saga are based at Lincoln, so we have a very good relationship with Saga. We've done that for many years, and then we're also looking at other areas. So where is the other areas that we're very interesting? Well, I sort of showed you the future of agricultural robotics a bit earlier. Phenotyping is one, so we think phenotyping is key. Picture of Norrin 10, discovered by Norman Borlaug, got the Nobel Prize, and that was the future of the green revolution. Probably that guy, through plant breeding technologies, probably saved more humans than any person who's ever survived. Why do we need plant breeding? Well, climate change, it's a real massive problem. This shows the Rothenstedt wheat yields. Look at the black line with the crosses. That's the Rothenstedt wheat yield going up and down since 2008. Why is that? It's the same variety. It's uncertainty, it's climate. So we're getting real problems. We need new technologies to overcome those uncertainties. Plant breeding has got to be key. We're interested in robots for phenotyping. This is our current work. Lots of ways to do this. There's lab-based phenotyping at the top, drones which you can use. We have drones at Rhizome if people want to do that. We have plant breeding plots this scale. Rothenstedt, this amazing scan analyzer robot which is in the middle. And then we're working on field robots with 5G. So it's a lightweight robot scanning crops, but one of the challenges is not just the robot, it's the data thing. The data scale is immense, so 5G we think is going to be key, and we have that facility at Rhizome. And then the other areas, the final one which we're really working on is crop care. People have been hoeing weeds manually for thousands of years. It's a good way of killing weeds. It's very expensive though. Then in 2000 and just after the Second World War, 2,4-D was invented. So herbicides came up, green revolution again, glyphosate came up, all sorts of environmental issues. Are we at the end of the road for herbicides? Question mark. I don't know, but I know that they're not being developed because they're so expensive to develop because of the environmental risk. So what's the alternative? We think robotics, so we're very active in this space, working very closely with a number of companies, particularly Garford, this is a robot hoe in 2020. Emerged from that Tillett and Hague thing in 1996. It was pioneered at Silso Research Institute, patented in the UK. Now it's taken a journey of 24 years, and it's a very powerful machine. Uses image recognition to do what's called green and brown recognition, where you're recognizing the crop row and weeding everything between it. We see lots and lots of opportunities now in AI for image recognition, and the target, the top is what's called green on green spraying. That's where you can identify a weed within a crop plant, identify the weed, locate it, and then kill it with precision tools or herbicides. And that's a really big challenge. You've got machine learning challenge, the data challenge, etc. So that's an area of active research that we're working on. So I know there's lots of people interested in machine learning, so please get in touch. And then you're using the same technology for crop forecasting, which we showed earlier with Raymond Kirk. So lots and lots and lots of opportunity. And all I'd say is please, if you want to get involved, please contact us. Please contact Eagle Labs. Please contact Lisa. We're a pretty open community. It's a great place to work and a great place to develop your agricultural technology solutions. It's all about collaboration in our view. And with that, I will hand back to the team.
Thank you, Simon. That was fascinating. Every time I listen to you speak, there's always a bit more information that I learn on there. So I've just got a couple of questions for you. What do you see that's the most important factors to aid the growth and sustainability of agri-tech and agri-food sectors?
Number one, I've probably said it, it's collaboration and it's the ability to network, and it's the ability to network across many areas, not just with farmers and growers and users and consumers. It's other technology developers, because some of this technology is really advanced, and you tend to find nowadays that you've got lots of specialist people who you need to link to help you. So how do you find those people? But then you've got all of the business side of starting a new business, and that's another challenge in its own right. So business plans, raising finance, raising capital. So I think when you embark on your journey, you've got many heads, and but the way that you bring it all together is just that ability to network and collaborate.
So if you could give those businesses just one piece of advice, what would it be? Invest
in time to go and meet people, network, and not just in seeing what your competitors do, but take a worldly view of what's going on, who's doing what, really trying to lock on to where that new innovation is going to come from.
I really agree on that one. The amount of businesses that I've spoken to, and it is just, sometimes it's not what you know, it's who you know and that information that they can impart for your business. So I highly agree on that one. So thinking outside the box then, if you could create or change one defining thing that could change the future of the sector, what would it be?
Oh, that's a hard one. Yeah, no, well, that one thing to do. Do you mean in tech or policy or regulation or?
I suppose in tech, because we know it's all going to kind of interconnect on there.
Yeah, the thing I'm really interested in at the moment is data processing, speed of data processing, and 5G. I'm really interested in that. We see lots of tech solutions. A lot of them hit the bottleneck in data processing, speed of data processing. So I'm really interested in that. It might not be 5G, it might be ways of doing it, it might be advanced processing technologies and all those sorts of things. So I go around processing. The other thing I wear my other hat, which I'm really interested in, is in data sharing and data exchange. So there's a real problem of how we get businesses to share and exchange data. Yeah. And I do think if we can get that sharing going, that's going to open up lots of opportunities for SMEs to develop new technologies. For example, a good one is decarbonising agriculture to try and get the consumer involved. How do we get consumers to buy food on the cost of carbon to produce food? It's really how do you get that data to them to make that decision? It's really difficult because the data doesn't get shared very easily. So if we can get that sharing and exchanging problem cracked, we can make real progress, and that opens up a new horizon for lots of innovation and lots of SMEs. Data.
data and more data.
Yeah.
Okay, fabulous. So that just leaves me to say thank you, Simon, for today's presentation, as well as you lovely viewers at home. If you would like to get in touch with Simon, or you have any further questions for myself about the Eagle Lab Farm or Eagle Labs as a whole, then please do not hesitate to email us at agritechteaglelabs@barclays.com. So I'm going to share a QR code with you in a second, and we would really appreciate it if you could take the time to give us some feedback to support us in creating future events that continue to educate and support the sustainability of agriculture. Thank you.